It is the device I have made at home, and it automatically switches off the power supply to electric water pump motor before overfilling of water tanks. The things which are used are BC547 transistor, a relay of 12 volts and DC battery of 9 volts, and some plastic pieces. Friends, in my previous video I have explained the model connections of automatic switch of power to electric motor. In that video I have taken a bulb instead of electric motor, and I have explained the connections, how relay and transistor are connected so that it automatically switches off power to electric motor after tank is fully filled. Friends, it is the device I have made. I want to explain the terminals. Here 3 terminals and here 2 terminals. These 2 are used to short, main for switching purpose, and this is the main supply to electric motor. Phase, this one. Switch is placed in between these 2 terminals. So coming to the theory, friends, here we can see 240 volts AC supply. Alternating current is the neutral terminal of this AC supply is directly connected to electric motor, but across the positive terminal phase line a relay of 12 volts is connected. So positive, the current comes here and it goes here and through this. Initially, when no current is passed across this inductor, it is in contact with this one, so current can pass through it and it goes here and directly to the electric motor. So water flows and that our tank will be filling. But we know when a voltage is applied across an inductor, it develops magnetic field across it, around it. So it develops north pole and south pole, and here to the switch a permanent magnet is attached, so that when current is passed across this inductor, it develops some magnetic field which attracts this magnet, and this magnet is attached to this switch. So this switch comes down, then the supply between this one and this one will be broken, so it acts as open. When will it act as open? When we pass some current to it. So by controlling when to pass current through this inductor, we can automatically switch off the power supply to our electric motor. So this inductor is connected to positive. This inductor is connected to DC supply. How many volts? 14 volts. Okay. The negative terminal of inductor is directly connected to the negative of DC supply, but positive, across positive, a transistor is used. For what purpose? As a switch. We know about a transistor. A transistor can be used in 2 different ways. One is as an amplifier and another one is as a switch. So collector is connected to the positive of DC supply, emitter is connected to the positive of inductor, and base, where to connect the base. So even though transistor is connected to the positive and negative, when it will be activated, we know that one. When base current is passed, it will be activated. We know about the transistor, when there should be some base current to activate the transistor, to make it act as a short circuit. Some resistance will be there, but a short circuit. So the base current should be passed to activate the component, otherwise no current will be passed to the inductor. So extend the base terminal and collector terminal, that means here positive current comes, so extended these two terminals, and when they are short, these two terminals are shorted, some current flows through base terminal. When these two terminals are shorted, when the tank is fully filled, it is these two terminals are kept at some height in the water tank. So when our tank is fully filled, these two are shorted, so at that time some base current will be flowing and it will activate our transistor. Then some current is passed to our inductor and it develops a magnetic field and it attracts the permanent magnet, and it will be opened. The contact between this one and this one will be removed. So friends, this is the working of automatic switch off, and I hope you all try to install this device in your home to reduce the wastage of water.